In this tutorial, we're going to be looking at a 2x2 ANOVA. The numbers when you describe an ANOVA indicate the number of variables you have and the number of levels for those variables. So 2x2 means you have an independent variable with 2 levels and another independent variable with 2 levels. Let's look at this example so you can see how that works. So the first independent variable is gender. In this data sheet we've only coded for male and female, so that's 2 levels. The second independent variable is which university participants attended, Kiel or Staffordshire. So again, that's 2. So that means a 2x2 ANOVA. If we coded for 3 universities, let's say we had Kiel, Staffordshire and Oxford, then it would be a 2x3 ANOVA, because this variable would have 2 levels and this one would have 3 levels. If we had an additional variable, let's say whether someone was in year 1, 2 or 3, then we would have a 2x2x3 ANOVA. 2 for gender, 2 levels, 2 for university, 2 levels, and then 3 for year of study, year 1, year 2 or year 3, and so on. If we had 4 variables, it would be the same. So in this ANOVA, it's only a 2x2. And we've got one dependent variable, one thing we're measuring, that's mean alcohol tolerance. So we're interested in who can drink the most. A higher number means higher alcohol tolerance. So to do this analysis, we go up to Analyze, General Linear Model, and Univariate. We've got our fixed factors here, so that's what SPSS calls our between subjects factors. It's very unhelpful that SPSS keeps using different terms for things, but never mind. We put gender in there and university in there. And then we've got one dependent variable, mean alcohol tolerance, and we put that in there. And if we click OK, that will do the ANOVA for us. But there's usually a few things that would be useful to do as well. I usually go to Options, I put all those in there. I click descriptive statistics as well. So that's just useful to see what's going on. This produces descriptives too, just a few different ones. There are a vast number of options you can choose here. I'm just doing the very basics. Click continue and OK. And here's the output. So first you can quickly check if your sample is all right. So we've got 20 people in each group. So 20 there, yeah. So this is all what we expected. 40 participants, that's good. Obviously that is a very small sample and this probably wouldn't hold much water really, but for a stats tutorial it's fine. But yeah, you would need more people than that to look at this really. So this tells us a bit about our descriptives. It's often a good idea to look at that first and see if you can interpret what's going on. So let's do that now before we look at the actual tests. You can see that for males at Kiel and Staffordshire, so males have a very high alcohol tolerance compared with Staffordshire, 7.90 to 3.20, and then that is the average of Kiel and Staffordshire for men. For females, we can see that Kiel and Staffordshire don't look very different. Okay, 5.10, 5.40, they're quite close, and that is the average for females for Kiel and Staffordshire. So then we can look at males and females. We can see that males 5.55 there and females 5.25. That's not very different really. And then the total for Kiel and Staffordshire 6.5 over 4.30. So let's look at that again. It looks like for males there's a difference. Those numbers are very different from one another. For females it looks like there isn't much difference. For males and females, it doesn't look like there's much difference either. And overall, for Kiel and Staffordshire, it looks like there is a difference. That's slightly bigger, 6.50, slightly bigger than 4.30. So you can have a quick look at this and just see if you can work out what you think is going on. We can't say anything for certain yet because we haven't checked our inferential statistics and looked at significant levels or anything like that. We can just have a quick look at this and see if it kind of is in line with what we might be thinking and seeing if we can understand it, just as an exercise in interpreting statistics. The key bit is down here in our test of between subjects effects. If we look along, we can see that for gender, there's not a significant effect. A very small F value and a large probability, so much greater than 0.05, 0.54, so that's no good. If we look at university, we can see a significant effect, so a very high F, P-value much greater than 0.05. It's even greater than 0.001. So there's a significant difference for university. And there's an interaction, gender, university. That's also significant. So we can look at our means again. If we scroll down, we've got similar information, but it just breaks it down by effect, which can be quite useful. So gender, no significant difference. If we look at gender, that makes sense. 5.55, 5.25, so no. Overall, there's no difference between males and females in our sample. For university, if we look at that, we can see for Kiel, there's a much greater value than for Staffordshire. So that's a significant difference. Kiel can significantly hold the alcohol better than Staffordshire. However, there's also an interaction. Now, usually when we do these kind of things, we start with the highest order interaction and work down, because main effects may be what's called subsumed into the interaction, i.e. that main effect might be caused by something in the interaction, and we'll see that here. Because if we look at our interaction, we can see that for males, there's a big difference, and for females, there's not. So it's likely that this overall difference between Kiel and Staffordshire is actually powered just by the males. Because that difference is so big, it's causing a main effect in the difference between universities overall. Actually, it's just happening for the males, whereas for the females, there's very little difference. Now, to be absolutely sure about this, we have to do some probing of this interaction, and that involves doing some t-tests. What we want to do is look at just males and see what the difference is there, and just females. If we look at it just eyeballing the data, I would suspect that that is going to be a significant difference here, but that probably isn't going to be a significant difference. But we always need to check. Sometimes very small differences between means can be significant. So let's look at males first. We go up to data and select cases, and we isolate the males in the sample. If condition is satisfied, click if, and we say if gender equals 1. So males are coded as 1 in this sample. Click continue and OK. If we look at our sample now, we can see that only the males are active and all the females are crossed out. So we won't be including them in any of the analysis. Then we go up to analyze, compare means, and independent samples t-test. Okay, because we're comparing Kiel and Staffordshire. People can only be part of one of those groups. So it's an independent samples t-test. As I said, SPSS confusingly uses all different types of names for different things. So our test variable is alcohol tolerance, we know that. And our grouping variable is university. So we put that in there. Now we have to tell SPSS which of our groups we're interested in. Well, we've only got 2 here. We have to pick 2, and we've only got 2. So that's nice and simple, 1 and 2. However, if this was a 2x3 ANOVA and we were looking at Kiel, Staffordshire and Oxford, we would need to be more careful what we put. If we wanted to compare Kiel and Oxford, for example, we would put 1 and 3. If we wanted to compare Staffordshire and Oxford, 2 and 3, and so on. So we have to be careful what we put. But we've only got 2 groups here, so it's very simple, just 1 and 2. Continue. OK. So there's our means. And if we look at our t-test, we can see very high T, there's our degrees of freedom, and significant difference. So that's what we thought. We thought there was going to be a significant difference, and there was. So we can say for males, Kiel have a much higher alcohol tolerance, significantly higher alcohol tolerance than Staffordshire. Let's now look for females. So select cases. If we change our gender to 2, females are coded as 2. If we look at our sample, you can see all the males are crossed out, and it's just going to be the females we look at. Analyze, compare means, independent sample t-test. It's all done for you. Nothing's changed. You're just looking at a different group. So university is still there, alcohol tolerance is still there. Click OK, and there we go. There's our means. And if we look here, T is very low. There's our degrees of freedom, and our p-value is not less than 0.05. So there's no significant difference. So if we scroll back up to our means, what we thought initially is correct. These two are significantly different. Males are significantly better at drinking than for Kiel than Staffordshire, but there's no difference for females. And this main effect of university here has been subsumed by this interaction. The difference between Kiel and Staffordshire here, this average, is driven by the males, not by the females. So that's how you would engage in a 2x2 ANOVA and then probe the interaction afterwards.